In this video, you will see how uh, first law of thermodynamics is being applied in solving problems related to heat, related to work, and related to the internal energy of a system involving gas. In our case, we have this problem where a gas expands doing 120 joules of work. Doing 120 joules of work. During this process, 30 joules of heat is removed from the system, and the question is determine the change in internal energy. So we want to figure out the change in internal energy. So first suggestion that I would want to tell you is, to advise, is to make sure that you write the equation corresponding to the first law of thermodynamics, which states that change in internal energy, which is the energy of the molecules, the energy of the atoms that is involved in the system, in our case it's gas, is simply equivalent to the amount of heat added or removed from the system and the work done to the system or by the system. So if you notice, I've been saying the words to the system and by the system and added or removed from the system. Okay, so there's a big discrepancy about if it's added or removed from the system. So my suggestion also, the second suggestion that I have aside from writing down the equation, is to draw a diagram which could be done this way, where we have a cylindrical object where we fill it up with gas. And then we will cover it with a lid. Okay, so this is your lid, not allowing any gas escape. Okay, so let's say the dots represents the molecules or the atoms of the gas. Okay, molecules of the gas. Okay, so based on the previous videos and based on the previous slides that you have seen, okay, what happens is when you add heat, what happens is that you build up excessive kinetic energy or excessive internal energy of the gas, or too much, or there is an increase of internal energy. So there's movement among the molecules or atoms. So what will happen is that this movable, okay, cover can move outside, or we can also push it inside. Okay, from previous videos, so you have noticed that when you push it, what happened? You build the pressure, and then as you build the pressure, the molecules started to move a little bit more compared to when they were spread all over the place. Okay, spread apart, and because of that, it will build up heat. Okay. So let's draw the information that we know from the problem. First thing that was mentioned is that the gas expands doing 120 joules of work. So the right side, where the movable lid, also known as the piston, okay, is where our work is. So let's write down 120 joules. Okay, 120 joules. It says over here that it expands doing work. So this word over here is very important. So it means that it is the system who's doing work. So therefore, the arrow, the direction of work, should be away from the system. Okay? And if it's away from the system, then it should be treated as negative. So it should be treated as negative because it's going away. It's being done. Okay, it's being done by the system. So this is the work. Now, on the other hand, where we have during this process 30 joules of heat is removed. So this one is very easy to remember because it's being removed. So when you remove something you want to remove, so it should go away from the system. And when it's going away from the system, it should also be treated as negative. So that's negative 30 joules, and this is our heat Q. Now in the problem, you were supposed to determine delta U, or the change in internal energy. Is it a decrease in energy, or is it an increase in energy? Is it a decrease or increase? Decrease or increase? Okay, so we will be able to figure out if it's an increase or decrease. So by applying this information right here, so let's put delta U, or our change in internal energy, is equivalent to Q. And since that is negative, so let's place negative 30 plus negative 120. By removing the parentheses, so that will give us negative 30, positive and negative. So this will bring out to be negative 120. So now we have a change in internal energy that is equivalent to negative 150 joules. Since this is negative 150 joules, so it means that there is a decrease in internal energy. So hope this will help in terms of way on applying first law of thermodynamics, also known as the law of conservation of energy. And see you again in the second example.